Okay, now let's get to know IP addressing. Okay, as have been explained in the previous module, so network layer is responsible to move data through a set of different networks, and the protocol that supports network layer uses hierarchical addressing. So IP address is the address that is used by network layer protocols. Okay. In encapsulation, so the network layer will include IP header. So this IP header consists of related IP address information. How to identify which part is the network, which part is host. Okay, the analogy is like this. For phone number, for the area code, for example, the area code is 831 like shown here, and the phone number is 40795783. So the area code is like the network portion, and the rest of the numbers are like the host portion. So for example, in Malaysia, so the code for each state is different. For example, in Terengganu, the code is 09. So this is like the network portion, and the rest of the numbers are like the host portion. Zip codes is like the postcode, so it will direct to your local post office and your neighborhood, and the street address then directs the carrier to your home. How IP address works is more or less like how conventional letter postage works. Bear in mind that, remember, for layer 2 we have MAC address, but this address is fixed even though you move the device to different locations. But for layer 3 address or IP address, it will change according to the location. You can check the IP address and the broadcast address by using command prompt. Okay, how to determine which part is network, which part is host. First of all, you have to remember that an IP address has 32 bits, so it has 4 bytes. Another name for byte is octet, and you can represent the IP address either in the binary format, which is in 0 and 1, or you could also represent it in decimal format like this one, 131.108.122.204, and these are in the binary format. Okay, how to determine which part is network, which part is host? We will use subnet mask, which will be explained later. Just to inform you that there are two types of IP addresses, classless and classful. But for our course, we only focus on classful and a little bit of classless for subnetting. Okay, let's try to use subnet mask. So for example, the first line 172.0.0.0, the subnet mask is 255.0.0.0. When you convert it to binary, is 1111.1111. So the network part is the 1-bit parts, and the 0 parts are the host parts. For example, this one also 192.4.0.0, the subnet mask is 255.255, which means there are 2 bytes that consist of 1 bit. So these 2 bytes are the network part, and the rest of 2 bytes are the host part. And for the last example, 192.168.140, the subnet mask is 255.255.255.0. So the network part consists of 3 bytes, and the rest of 8 bits is the host part. Okay, subnet mask can be represented either in dotted decimal notation or in slash notation. slash notation, for example, like this one, 255.0.0.0, when you convert it to binary, you will get 8 bits of number 1. So you can represent it as slash 8. The same here, you can represent it as slash 16 because there are 16 bits of number 1. And this one is slash 24 because there are 24 bits of number 1. Okay, why the subnet mask matters? Like we said before, you can know which part is network and which part is host, and then you can determine how many hosts for each network. So this is for class A, where the network part is only 8 bits, so this is very suitable for large organizations. This is for class B slash 16. This is for class C slash 24. So it means that with more bits of network, there will be less bits of hosts. Okay, let's try this one. Network address and broadcast address. How to determine the network address and broadcast address? To determine network address, you need to make all the host part to 0. And for broadcast address, you need to make all the host part as 1. So that's why we get for network address 172.0.0.0 by using subnet mask /8. So you get the broadcast address as 172.255.255.255. I will explain this little bit more detail in the next video. So the host addresses are the range of addresses between the network address and the broadcast address. For example, like this one, you get 172.16.0.0 with subnet mask of /16. So the broadcast, the network address, you make the host part as 0, so you get network address 172.16.0.0, and the broadcast address, because you make the host part as 1, so you get 172.16.255.255. So the range of host addresses that can be used is 172.16.0.1 until 172.16.255.254. So another way to check is 2 to the power of bit of host, which is 2 to the power of 16 minus 2. Okay, why minus 2? Because 2 are for network address and broadcast address. So the subnet mask doesn't have to be in natural boundaries, which means it doesn't have to be /8, /16 or /24. It could also be /21, /23, /27, for example. So otherwise we cannot do subnetting. For example, like this one, 172.1.16.0, and the subnet mask is 255.255.240, which is /22. Yes, /22. So you make the host part as 0 for network address, and you make the broadcast address. To get broadcast address, you make the host part as 1. So that's why you get network address as 172.1.60.0, and the range is from 0.1 until 172.1.31.254, and the broadcast address is 172.1.31.255. Okay, so why subnetting? We will explain this in the next video. Just for your information, all the notes are referred according to Rick Graziani notes from Cabrillo College. Thank you.